All right, y'all. So let me get us back on question one here. All right, so question one, they're giving you a polynomial and they want you to determine what the end behavior is going to look like. So, y'all, for this question, I'm going to go by this little chart we made. You look at the degree, even and odd, and then the lead coefficients. Okay, so that's the chart I'm using on that problem. All right, y'all. So the highest exponent is 3, so that's a degree 3 polynomial. Square root of 5 is positive. So when you got an odd degree and a positive lead coefficient, what would y'all choose? A, B, C, or D? All right, y'all, so let's get our chart out. So we got a positive lead coefficient and an odd degree. So my odd degree puts me on the right side. It's either going to go uphill or downhill. And since that lead coefficient was positive, that's going to go uphill, left to right. So we want the one going uphill, left to right, y'all, and that would be D. So just throw a D in there and hit next. All right, y'all, so number two, I'm going to write that down real quick and then we'll work it out. F of x equals x to the third minus 10x squared plus 13x plus 37. And they want to know, is 4 a 0? All right, y'all, so a 4 is going to be a 0 for that. When I plug it in and I work it out, I better get an answer of 0. So we're finding f of 4 now to equal 4 cubed minus 10 times 4 squared plus 13 times 4 plus 37. All right, so I'm going to start the exponents. So the 4 cubed and the 4 squared. So 4 times 4 times 4 is 64 minus 10 times 4 squared. So 4 times 4 is 16. And then, y'all, I'm just bringing everything else down. So now I did my exponents. Now I'm going to multiply. So I'm going to bring down my 64 minus 10 times 16 is 160 plus 13 times 4 is 52 plus 37. So now, y'all, we would just throw that in the calculator and see what we get. 64 minus 160 plus 52 plus 37. All right, y'all, so when I threw that in, it gave me a -7. So since we got a -7 for that answer, that means no, 4 is not a 0 of that polynomial. So y'all, that one should have been what a yes or no. So we said no. So if you get a 0 on that one, yes. Any other number, no. All right, y'all, number three, they're giving us a polynomial, x to the third times x minus 5 squared times x plus 8. And y'all, looks like on this one, they want us to find the smallest zero first, multiplicity, middle zero, multiplicity, largest zero, multiplicity. So let's go work these out real quick. Once we find our zeros, we'll figure out their multiplicities because of the exponents. And y'all remember, the last x plus 8 don't have an exponent out by it, so it is definitely a 1, okay? So you had to take all the factors and set equal to 0. So I'm going to set the first one, x equal to 0, x minus 5 equal to 0, x plus 8 equal to 0. So this one's already solved, basically. Anytime you got a single variable like that, it's always going to equal 0. The second one, we would add 5. And then the third one, I would subtract 8. So we got the smallest, middle, and largest. So the smallest zero is negative 8. And that negative 8 came from the last factor, which had a multiplicity of 1. The middle one would be 0. It came from the first factor, which had a multiplicity of 3. And then my largest zero would be the 5. It came from the second factor, which had a multiplicity of 2. All right, so here we go throw them in Math Lab. Smallest zero we said was negative 8. Multiplicity of 1. Middle zero was 0. And it had a multiplicity of 3. And then my largest zero was 5. And it had a multiplicity of 2. So, y'all, basically that problem is taking each of the factors, setting them equal to 0, okay? And then using them outside exponents for your multiplicity. All right, also number 4 here, you got a 4-term polynomial. This is the one where we factored by grouping. So let me write this down. X cubed minus 6x squared minus x plus 6. All right, so the trick is to solve this one. Once you got it solved, then figuring out those multiplicities. All right, so 4 terms. This is the one where I grouped the first 2 terms together and the second 2 terms together. I factored out the greatest common factor from each of these pairs. So for the first 2, you got an x3, negative 6x squared. Their greatest common factor would be the x squared. So both of those have at least an x squared in them, right? So if you take out that x squared and divide it out, x cubed divided by x squared leaves you an x minus. And then on the 6x squared, when you divide by the x squared, those x squareds cancel, and you're left with that 6. Now remember, we said automatically the second GCF has to have the same sign as the third term. So since that x is negative, your second GCF will be negative. And y'all, there's only one thing I can factor out as a common factor between an x and a 6, and that would be a 1. So I'm factoring out a negative 1. So when you divide both these by negative 1, negative x divided by negative 1 makes that a positive x. 6 divided by that negative 1 makes that a negative 6. It is really important at this point, your parentheses gotta match up, okay? So if your parentheses don't match up, you need to figure out those GCFs again, okay? So since both of these have an x minus 6, you're sort of going to factor out that x minus 6. And then in the second parentheses, put what's left. Well, the x squared, x minus 6, if you divide out the x minus 6, leaves the x squared. And then your negative 1 times x minus 6. If you pull out that x minus 6, you're left with the negative 1. So the stuff in the parentheses makes up one parenthesis. The stuff on the outside makes up the second parentheses. All right. At this point, I'm going to set each of my factors to 0 so that I can solve them. Now, neither of these have an exponent on the outside, so we treat the exponent like a 1. So all my zeros will have a multiplicity of 1 on this one. And y'all remember, you need 3 zeros because that had an x to the third, okay? And then I'll set x squared minus 1 equal to 0. So y'all, the first one, I'm just going to add 6 and be done. So we get x is a positive 6. On the second one, I got an x squared term in the number. I'm going to add the number and do my square roots. So the square root of x squared will equal to square root of 1. So square root of x squared was x. Square root of 1 is a plus or minus 1. So your zeros on this one are going to be 6, 1, negative 1. All have a multiplicity of 1. And y'all, I think everybody's on that one has a multiplicity of 1, okay? All right, so first you put in your zeros. You had a 6, comma, 1, comma, negative 1. And then each had a multiplicity of 1. Okay, so that's the trick on that one is do that factor by grouping. Alrighty, so this is the ones where we said we're going to look at the exponents of the factors. So the x minus 8 has a 6, the x plus 1 has a 7. If the factor has an even exponent, it would be tangent to the x-axis. If the factor has a odd exponent, it crosses right through that x-axis. So they are saying that this polynomial crosses the x-axis at 8, 0. So we got to look at which factor the 8 would come from. And y'all, that's the x minus 8. It has an even exponent of 6. Well, we said even exponents were tangent to the x-axis. So this is definitely false. So you got to pick the one where the exponent is even on it, okay? Because see, one of them says the exponent 6 is even. One of them says the exponent is odd. What's the even exponent? So I'm going with B. And B says, since it's even, the graph is actually tangent, which is true. So y'all, look at which factor that x-intercept came from, and then look at those exponents. Even, tangent, odd, crosses over, okay? And then pick the one that has the right even or odd for those exponents. All right, y'all, so this is one for y'all. They're giving you a function. They want to know the maximum number of zeros, maximum number of x-intercepts, and the maximum number of turning points. So you got a negative 4x minus x to the 7th. So y'all, the question is, what's the maximum number of real zeros? And y'all on that one, remember that the maximum number of real zeros and the maximum number of x-intercepts are both equal to the degree. So on this one, my degree, my highest exponent is a 7. So that means the maximum number of real zeros and the maximum number of x-intercepts are both going to be 7 because they're equal to the highest exponent. The turning points, however, were equal to the degree minus 1. So the highest exponent minus 1. Well, we said the highest exponent was 7. So if you subtract 1 from that, you get a 6. So y'all, these will always have the first two numbers got to match, and then your last number has to be one less, okay? Oh, y'all, let me make these graphs a little bigger. And they're basically wanting you to use that chart we used for number 1. Um, so this has a degree 2, because of that x squared, that's a degree 2. And you got a positive lead coefficient, that 1/5. So that's a positive 1/5. So remember, when it was an even degree, it either went both sides down or both sides up. Well, y'all, since that's a positive 1/5, that means both sides would go up and look like A on that one, okay? So A and B were your positive degrees. C and D were from your odd degrees, okay? And that all goes back to that chart I showed y'all on the very first problem, okay? And y'all, this is basically the same thing. So let me make these a little larger. But this one is an odd degree of 3. The highest exponent is a 3, which is odd, and you got a negative 1 in front of it. So you got a negative degree, so it's either going to go, an odd degree, so it's either going to go uphill left to right or sort of downhill left to right. Since that's a negative 1 in the very front, that thing is going to go downhill left to right and look like D. So once again, that one would definitely use that chart. Or remember, you can graph these and get the pictures, but you want to set your calculator to the same numbers that they got on their graphs, okay? So on that one, if I was going to use my calculator, I would hit my window, set my X's from negative 10 to 10, and my Y values from negative 100 to 100. If you match their window, you'll get one of them pictures exactly, okay? All righty, y'all. So this is where we started doing all that foiling. So this was out of 8.4. So they're giving me a negative 3, 4, and a negative 5. So we got a couple here where we're going to be doing some foiling. And y'all look at that. They're giving me everything on the answer except what number is going to be in front of that x squared. So when we're done foiling, it better look like that, okay? All right, so let's go. Since these are zeros, that means they were solutions. And these were the problems where I worked in reverse. I needed a 0 on the right side of each of these. So I'm going to add the opposite to both sides. So I get an x plus 3 equals 0. Add the opposite of 4, which is negative 4 to both sides. And then the opposite of a negative 5 would be a positive 5 to both sides. And I get x plus 5 equals 0. So once I had my three equations equal to 0, I threw them all in parentheses and set this whole thing equal to 0. All right, so then we had to start foiling. So what I do, I usually foil the last two. So I'm going to bring down that x plus 3. And we'll multiply by whatever we get out of this. So I usually do those on the side. So if I do them on the side, it keeps me from having to keep rewriting everything as I go through, okay? All right, so we had an x times the x is an x squared. X times 5 is 5x. Negative 4 times x is negative 4x. Negative 4 times 5 is negative 20. I'm going to add my like terms, so I get an x squared. 5 and negative 4 leave me 1x, and then minus my 20. So that's going to go over here now. X squared plus x minus 20. So now I'm going to multiply all this. So we're going to take the x, distribute it, and then the 3 and distribute it. So it's like FOIL, but you got that extra step on each one of them, okay? So x times x squared was an x cubed. X times x is an x squared. X times negative 20 is a negative 20x. 3 times x squared is a 3x squared. 3 times x is a 3x. 3 times negative 20 is a negative 60. All right, y'all, at that point, I'm just going to add like terms. So I'm going to bring down my x cubed. Let's see, on the x squareds, I got 1x squared there, 3x squareds there. That's going to give me a positive 4x squared. On my x's, I got this negative 20x and a positive 3x. That's going to give me a negative 17x. And y'all, at the end is my minus 60. So all they were looking for was what number's in front of the x squared. And y'all, that's going to be a positive 4. But y'all look at that. All the rest of our numbers are going to match also. So let's go to MathLab. So see, they got the negative 17x minus 60. All you had to do is come in here and put in a 4 on that x squared, okay? All right, at that point, hit next. So this one's the same thing, except you got radicals on here. Square root of 6, negative square root of 6, and 4. So it's the same thing. Now, they're giving me A, B, C, D answers on this. So let's go see what we get. Hey, y'all, so me, I'm a little pickier on these ones. I like to bring my real number out front, so I'm going to do my x equals 4. Then I'll do my x equals square root of 6, x equals negative square root of 6. Same thing, I want zeros on the right side like Walgo, so subtract 4 on the first one. X minus 4 will equal 0. Subtract the square root of 6, so that x minus square root of 6 is 0. And then the last one, add the square root of 6. So x plus square root of 6 equals 0. All right, y'all, so at this point, we're going to put them all in parentheses. So, y'all, this problem is just like the one before. The only difference is you have to deal with these radicals, okay? So when you're doing this problem, you definitely want to FOIL the radicals first, okay? So on the side, let's do our x minus square root of 6, x plus square root of 6. Now listen, since these are conjugate pairs, I'm not going to FOIL this whole thing. I'm going to shortcut it again. Because conjugate pairs, all you got to do is multiply the first two terms together, x times x, and get an x squared. And then multiply the last two terms together. So you got a negative and a positive. We'll make that a negative. And y'all remember, we said a square root of 6 times the square root of 6 equals 6. Remember, square root of anything times itself equals the number that was under that radical, okay? All right, y'all. So I'm going to bring down that x minus 4. And then I'm going to put in my x squared minus 6. So now 2 things times 2. I'm going to FOIL these. And y'all, since it's the last thing I'm foiling, I'll just do it right here. So the x times x squared is an x cubed. X times negative 6 is a negative 6x. Negative 4 times x squared is a negative 4x squared. And y'all, finally, negative 4 times negative 6 is a positive 24. And y'all, out of all this, the only thing I'm going to do is flip-flop these two to put them in order. So x cubed minus 4x squared minus my 6x plus my 24. So I'm looking for a polynomial on ABCD that looks like that, okay? So let's go back to the math lab. So I had an x cubed minus 4x squared. So it's got to be C. And then there's my minus 6x plus my 24. So when you fold that out, you got to get one of them four answers, okay? All right, also, this one was just wanting you to figure out what the other two zeros were. So they're giving you a negative I and then an 8 minus square root of 13. Well, both of these have conjugates. So the conjugate of a negative I is going to be a positive I. And then comma, the conjugate of an 8 minus square root of 13 is going to be an 8 plus square root of 13. So that one, they're giving you 2. They're telling you it's a degree 4. So you should have 4 zeros altogether. So you had to find those other 2. Okay? Now, remember, this is 2 numbers. Some people treat it like 3. But y'all, the 8 minus square root of 13 is a single number, okay? Alrighty, y'all. So, next. Alrighty, y'all. So, number 12, they're giving me zeros of a negative 4i and 6. They want me to find the polynomial of lowest degree and that has the given numbers as sum of its zeros. Well, that means, based on the last problem we did, if this is sum of my zeros, this negative 4i, since it's imaginary, its conjugate must also be a 0. So that means 4i must also be a 0. So on that problem, that's the first thing you had to realize. Then you had to set these all equal to 0. So start out with x equals 6, x equals negative 4i, x equals a positive 4i. So it's another one of those foiling problems. The only difference between it and the ones earlier is they're not giving you all the zeros, and you got to realize that the i's definitely come in conjugate pairs, okay? All right, at this point, I'm going to solve it like I have been. I'm going to subtract 6 on the first one. add 4i to my second one. On the third one, I'll subtract 4i. All right, three equations equal to 0 again. Put them all in parentheses. All right, so what I'll do, I'm going to start out by filling in the imaginary stuff. So bring down that x minus 6, and that'll multiply by whatever we get out of this imaginary. So what do we got? X plus 4i, x minus 4i. All right, conjugate pairs again, so you can fast track this and do the shortcut method. So first off, you got an x times x, which is an x squared. Now, y'all, here's where you got to watch out. 4i times negative 4i is a negative 16i squared. But do y'all remember what I squared equaled? All right, good job. That equals negative 1. So you're technically going to replace I squared with negative 1. And what it's going to do, negative 16 times negative 1 is going to make that a positive 16. So the radicals won't go when you FOIL them, they were negative. The imaginary numbers will always end up positive, okay? All right, y'all. So the last step, FOIL this and be done. Now remember, I had 3 zeros, so I'm going to end up with an x cubed on this one. X times x squared is my x cubed. X times 16 is a 16x. Negative 6 times x squared is a negative 6x squared. And y'all finally, that negative 6 times 16 is a negative 96. So the only thing you would do at that point would be to put it in order. So x cubed minus the 6x squared plus the 16x and then minus the 96. Now all we're putting in MATLAB is this. We don't have to put the equal 0 or nothing like that, just the actual polynomial. And no, I don't think that one had an answer for it, did it? We had to put the whole thing in. Yeah, so here we go. We had an x cubed. So x, go down here and get the exponent and cube that. Arrow right, minus 6x. Come down and get the exponent for the square. Arrow right and come down. What was next? Plus 16x minus 96. So on that one, you just put the polynomial and be done with it. And then we're going to hit next. All right, y'all, let me see. Let me write this one down real quick. So this is 13. They're giving us P of x equals x to the fourth plus 16x squared minus 225. And they're telling me 5i is a 0. So they want me to find the rest of the zeros, okay? So y'all on this one, the first thing I'm going to realize, that's the x to the fourth. So when we're done, we need to find 3 more zeros. They gave us 1. We're going to find the other 3. So this is where I did my synthetic division. So I'm going to start out with that 5i they gave me first. I'm going to write out all the coefficients. But y'all notice I don't have an x cubed term or an x term. So I'm going to use zeros as placeholders. So we got 1x4, 0x cubes, 16x squareds, 0x's, and then my constant term at the end is a negative 225. All right, this is where I draw my line and I boxed under the last number. Now, since they gave me this zero, we better get a remainder of zero for this one, okay? So, y'all, we bring down our 1. 1 times 5i is 5i. 0 plus 5i is 5i. Now, 5i times 5i is 25i squared. But remember, I squared equals negative 1. So that's really 25 times negative 1, which is a negative 25. All right, 16 and negative 25 is a negative 9. Negative 9 times 5i is a negative 45i. 0 plus negative 45i is a negative 45i. And y'all, that negative 45i times 5i is a negative 225i squared. But remember, I squared is negative 1, so that's going to make that a positive 225. When you add them together, you get a remainder of 0. All right, so now you bring these four numbers down, 1, 5i, negative 9, and negative 45i. So since you got four zeros, you got to do synthetic division for the first two. And then once I got three numbers here, that's when you can do the quadratic stuff. Quadratic formula, solve it by square roots, factoring, any of them methods that work, okay? Oh, y'all, here's the question though. What's the next zero I need to check? Because they didn't give me nothing but that 5i. Perfect. It's got to be the negative 5i, y'all. Because these come in conjugates. So the only clue was that these come in conjugates. So you got to use that negative 5i, okay? So for the other zeros, I know for sure the first one is negative 5i. So let's do this, and we better get a zero here, okay? So we bring the 1 down. 1 times negative 5i is negative 5i. 5i, negative 5i. 0. 0 times negative 5i. 0. Negative 9 plus 0. Negative 9. Negative 9 times negative 5i is a positive 45i. And when you add that last column, you get a 0 remainder. So now remember, these are the coefficients of the polynomial. So this is in the x squared position. So you got 1x squared, 0x's minus 9. At that point, you're going to set these last three numbers equal to 0. So remember, that's the x squared column, x, and then the constant term. And y'all, the way I solve this one, I'm just going to add 9 and do square roots. So I get x squared equals 9. I'm going to do the square root of both sides. So that's going to give me an x equals a plus or minus. Square root of 9 is what, a 3? So the other zeros are going to be the negative 5i positive 3, and negative 3. Now, I think MATLAB will give you all that plus or minus option on that one, right? Let me go see. So if I hit the answer blank, I had negative 5i. And then comma. Oh yeah, I can use the plus or minus 3. So use plus or minus on that one or 3 comma negative 3, okay? Either way, that will work. All right, y'all, let's hit next. All right, so this one was what? Vertical asymptotes. So let me write that down. So we got f of x equals x squared plus 2x minus 15 over x squared minus 4x minus 21. All right, y'all. So this one is vertical asymptotes. We found them the same way that we do domains. We're going to take the bottom, set it equal to 0. All right, so on this one, I'm going to factor it into parentheses. So everybody's number 14 will factor, okay? So x squared is an x and an x in the front. The last number's negative here, so you got unlike signs. One's positive, one's negative. So we need factors of 21. So that'd be what? 1 and 21, 3 and 7. One pair of these factors will subtract and give me a 4, and that's going to be the 7 and 3. Now remember, when you got unlike signs, the larger number has the same sign as the middle number. So y'all, the 7 is negative, and the 3 would be positive. All right, to finish it off, set both these equal to 0. Solve both of these. So the first one, we just subtract 3 from both sides and get x equals a negative 3. This one I would add 7 and get x equals a positive 7. Those are the two possible asymptotes, but remember, I need to at least factor the top to make sure none of my factors cancel, okay? So you had an x squared plus 2x minus 15. That's going to factor into two parentheses. X and the x for that last number is negative again, so you're going to have unlike signs. And I'm looking for factors of 15. 1 and 15, 3 and 5. The factors that'll subtract and give me 2 are 3 and 5. The larger number 5 is positive, like the middle number, and the 3 will be negative. So at this point, I had an x plus 3. That's an x minus 3. They do not cancel. So that means we keep both of these vertical asymptotes. So we want both the negative 3 and the 7. So that one was what, oh, y'all, look here. They're being a little tricky. A has x's. D has y values. Well, we only used the y values when we was messing with them horizontal asymptotes. So y'all be careful. You want the one that has x equals negative 3, x equals 7, okay? All right, so 15 wanted the domain. I got f of x equals 3 over x squared minus 2x minus 35. All right, y'all, so to find the domain, we're going to set the bottom equal to 0. Whatever answers we get, we're going to kick them out of our intervals doing the union, okay? So set this equal to 0. I'm going to factor this. So x squared is an x and an x. Once again, that last one's negative. So I got unlike signs. Um, let's see, I'm looking for factors of 35. That's 1 and 35. And what else? 5 and 7. The pair that'll subtract and give me 2 are 5 and 7. The negative in the middle means the larger number is negative, so the 7 is negative, and the 5 is positive. All right, at that point, set both them equal to 0 and solve. So on that first one, I'm just going to subtract 5 from both sides. I get negative 5. Second one, I'd add 7 to both sides and get x is a positive 7. So they wanted interval notation. So let's see, these are in order. So start at negative infinity until we get to negative 5. Union around that negative 5 to kick it out. From negative 5, the next number we got to kick out is 7. So we're going to union around that 7. And then 7 is the last number I'm kicking out. So then I head off towards positive infinity. So we're kicking out to negative 5. We're kicking out to 7, okay? So let's see what Math Lab wanted. Okay, they wanted it in interval notation. So parentheses, negative infinity, comma, negative 5, close parentheses, use your union, open up parentheses, negative 5, comma, 7, close parentheses, grab your union, and then this one went from what? 7, comma, half infinity, and close your parentheses. Okay, so definitely they wanted interval notation on number 15. All right, what's next? 16. All right, y'all, so let's me stop my share for a second. And I'm going to pause it. All right, so let me go back to Math Lab. All right, y'all, so this one is a horizontal asymptote. So I got 3x to the fourth plus 4 over 2x to the fourth minus 3. All right, y'all, so let's go to the pad and work that one. So you had 3 cases of horizontal asymptotes. The degree on top was higher, then there was no asymptote. The degree on bottom was higher, it was y equals 0 for the asymptote. And if the degrees were equal, like this one is, the degree on top equals the degree on bottom. So when the degrees were equaled, our asymptote was a over b, where a over b are the lead coefficients in front. So this would be what, a 3/2. So we're wanting the answer that has y equals 3/2 for our horizontal asymptote. Remember, horizontal had y, vertical had the x's, okay? All right, so that was 3/2. So let me go to MATLAB. And they got the y equals already, so you shouldn't miss that because they've already got the y equals. So just come in and put 3 divided by 2, and then be done with that one. All right, so this one wanted me to find the domain. So this is 17. F of x equals 5x plus 2 over x. So they want me to find the domain and the x and y intercepts on this one. So let's go play with it. And then we'll use our calculator to graph it, okay? So for the domain, I set the denominator equal to 0. Well, y'all, when you set x equal to 0, the only number I need to exclude is 0. So my domain will be from negative infinity to 0, union around 0 to kick it out, and then go off towards positive infinity. And then it wanted the x-intercept, y-intercept. The x-intercept, you find it by setting the numerator equal to 0. So you're going to set 5x plus 2 equal to 0. And we're going to solve that. So we'll subtract 2 first. So that gives me 5x equals negative 2. Then divide both sides by 5. So I get x equals a negative 2/5. So that means the x-intercept will be negative 2/5 and 0. Remember, the y value is always 0 for your x-intercept. And you got to put it in like this, like an ordered pair. The y-intercept, we find f of 0. So f of 0 means put a 0 in for both the x's. We all look at that. We got a 0 in the denominator. That means this thing's undefined. Since this is undefined, that means there is no y-intercept. Okay, so then we had to graph this. So I'm going to go to the calculator, go to y equals. I'm going to hit alpha y equals enter to make it look like a fraction. On top, I had 5x plus 2. On the bottom, I had x. All right, so let's just see. Let me go back and see what they got their window set on that. So y'all, they got negative 10 to 10 on some of them. But that very first one looks like negative 20 to 20. So let me just go see which one my picture is going to look like on my calculator. So hit graph. So it's coming down on the left side. And right there where it's sort of, that's about 5/2. That's about 5 because remember my horizontal asymptote would be 5/1, which would be 5. So y'all, let's just find a picture that looks like that. All right, so I'm going to look one more time, just look at that picture. All right, so we're down on the left side. Okay. So looking at that, I'm thinking C for me. Because C came down on that left side. Remember, it can't cross over to 0 for the, it can't cross over the y-axis because there was no y-intercept, right? So it's got to be C. So let's see, let's pick this. Negative infinity to 0 was our domain, so that'd be B. The x-intercept was parentheses, negative 2/5, comma, 0. And then there was no y-intercept because we said that was undefined. So put them three in and then pick your graph and then hit next. All right, so 18, 19, and 20, we're just solving the inequalities. So this one was an x minus 1, x plus 3 has to be less than 0. All right, y'all, so let's go solve that one. So y'all, since this one's already factored, you can come in and set each factor equal to 0. Solve this, and then I'm going to set up my little number line, okay? So y'all, the first one, add 1 to both sides, and you'll get x equals 1. And then the second one here, I would subtract 3 from both sides and get x is a -3. So then you set up your number line. So let's see, -3 would be here, and +1 would be there. I'm going to test 0, and 0 is going to be in between -3 and 1. So to test 0, I'm going to put a 0 in for both those x's. 0 minus 1, 0 plus 3 has to be less than 0. So y'all, that's going to give me -1 in the first parentheses times 3. And that's going to be less than 0. And y'all, -1 times 3 is -3 less than 0. That is true. So since it's true, you're going to shade the section where 0 was located. And then write your answer in interval notation. Since this is less than and there's not an equals under it, my interval will be a parentheses, and it's going to go from -3 to 1, and then close parentheses. Remember, it's parentheses. If you got an equals under it, then it's going to be the brackets, okay? All right, y'all, so let's go put that in. So you put the solution set is parentheses, -3, comma 1, and then close parentheses. Okay, so that's a trick on that one. 19 will be another one we got to solve. This one, though. X squared minus 11x plus 24 has to be greater than 0. So, y'all, the trick on this one is we got to factor it so we can solve it. So I'm going to set it equal to 0 after I factor it. X squared is an x and an x. Now y'all here, watch this. The last sign's positive. If the last sign's positive on these polynomials, both signs will be negative like the middle. And if that was a plus 11x, both of these would be positive like the middle. So if the last one's positive, both of the factors have to have the same sign as the middle. All right, now you want factors of 24. Factors of 24, since that's positive, you want factors of 24 that add to get 11. The only factors that add to get 11 are 3 and 8. All right, y'all, at that point, solve these two by setting them each equal to 0. So here we're going to add 3 to both sides. And that'll give me x equals 3. On this one, I'm going to add 8 to both sides and get x equals 8. So for my number line on that one, let's see, the order would be what? 3 and 8. If I'm going to test 0, 0 is going to be off in this first section. This first section goes from -infinity all the way to 3 there, okay? So I'm going to test 0 again. I'm going to put a 0 in for my x's. I got 0 squared minus 11 times 0 plus 24 has to be greater than 0. Well, y'all, that's 0. That's 0. So I get 24 greater than 0. That is true. So since that's true where 0 is located, I'm going to shade the left side. And y'all remember, anytime you shade the left side, you automatically got to shade the right side. which means this interval is going to cover all the stuff on the outsides. You're going to go from negative infinity to 3, union, and remember, these are parentheses because there's no equals under that. And then it's going to union from 8 to positive infinity. Remember, it's going to be false for this. So from 3 to 8, we cannot include 3 to 8 in the interval. It's got to be everything before 3 and everything after 8, okay? All right, y'all, so you would go put that in. So we'd start with parentheses, negative infinity, comma, that went to what, 3, and then union, parentheses, from 8, comma, to positive infinity, and then parentheses. Okay, so that one's done. So we hit next. So number 20, I got an x squared plus 20 less than 6x. All righty, so same thing on this one. I need a 0 over here, so you're going to have to subtract 6x from both sides right off the bat. Now, putting this in order, I'm going to have an x squared minus 6x plus 20 less than 0. All righty, so now I'm going to factor this and set it equal to 0 while I solve it. So x squared is an x and an x. The last sign is positive again, so both of these factors will be negative like the middle. And y'all let me find some factors of 20. That'll be 1 and 20, 2 times 10, 4 times 5. Since that's positive, I want a set of factors that'll add to get a 6. Well, y'all look here. None of these factors will add to get 6. So since none of my factors will add to give me the 6 in the middle, this one does not factor, which means it's a no solution. And remember, in MATLAB, for no solution, we got to use the 0 with a line through it, okay? So let's see how it, once you click the box, down here on the bottom, right by more, you see the 0 with the line through it. That means empty set because there's no solution to it. So click that. It'll put that in the answer blank for you. And then, oh, this is the last one, right? Number 20. So then you just submit that thing. And you're going to be done with it, okay? All right, y'all. So that was all that was on our agenda for today. Was knocking out that module review. Tomorrow we will start 9.1 and 9.2 and start getting through our last module test materials. All righty, y'all. So I'm going to stop my recording so I can send this out in a little bit.